Alright, so here we go. We're going to start with number 12 because if we can do the slightly harder ones, then the easier ones should be a piece of cake. Alright, you were asked to write a polynomial function of minimal degree. Okay, because it says of minimal degree, all my fancy schmancy people out there, and you know who you are, that means we're not going to make it bounce at a root if we don't need to.
Okay.
We're not going to have multiplicity at any of these roots unless we have to. So we're just going with these single factors right here. Now, the other thing is, don't add any vertical stretches or compressions in, because all that does is open the door to arithmetic error, which will make you cry if you do all the hard work right and then you try to get fancy and then you mess up. Okay? So we're going basic here because basic is good enough. All right, this problem has 1, 2, 3 roots. Do you see them? Now, this is complex. Is its conjugate there? Yes. So, you know how sometimes I get a complex and I have to write the conjugate because it's not there. Now remember, with every complex number, whether it's listed or not, like number 16, sneaky.
1 minus 2i.
1 minus 2i is also a root because with our complex, they come in pairs. Okay, so it's already listed, so we're good there. And since there's 1, 2, 3 of them, we know at the end, when we get it in standard form, that leading term will have a degree of 3 because we have 1, 2, 3 roots. All right, so let's start it out. We're writing the function. If -4 is the root, what is the factor? X plus 4. Very good. Okay, so remember, if A is a root, then X minus A is the factor, right? So when we get this one right here, 1 minus I, and we have to subtract that, it becomes X minus 1 plus I, because we have to distribute that negative. So it's going to change this sign and that sign.
Wait, what? Okay, wait. So wait, the negative, wait, the other side's flipped?
Yeah, because we're subtracting it. Yes,
Okay.
sir.
Is there a shortcut to multiplying the factors?
If you discover one as you're working today, that's fabulous. But we're not going for the shortcut trick here. And even tomorrow, you know how sometimes y'all walk in the next day and I'm like, surprise! Yeah, there's no surprise tomorrow.
Oh.
There's not a shortcut. Okay? Alright, so we're going to do subtract this root now, and we get 1 minus I.
So either way, it's going to be 1 minus and 1 plus I.
It's going to be 1 minus and 1 minus. What ends up changing is this plus I and minus I. Okay, so whenever we start multiplying everything back, it is easiest to start with those conjugates. So here we just have one set of conjugates. So we're going to start by multiplying these two factors back together. Now it's a trinomial, and a trinomial, the way it's written, if we thought about it as individual terms instead of x minus a complex number. So we're going to have to distribute the x all the way through, then the -1 all the way through, then the I all the way through. So it's not hard, just a little tedious. So let's take the x all the way through, and that's going to give us x squared minus x minus ix. And you see that's distributing this x throughout the second factor. I'm going to change colors so that you can see what happens now when we distribute the -1. So the -1 is just going to change the signs of everything, right? Makes it a negative x, a plus 1, and a plus I. Yes, it's best to be very careful with your simple arithmetic. Yes. Alright, so now we're going to distribute the I all the way through. So that just causes an I to be multiplied times everything that's there. Okay, so then we get a negative I squared. Okay? And that will make a positive 1. That negative I squared makes a positive 1. Now, if we did our arithmetic correctly, all the imaginary parts will cancel out at this point. So if I look at it, I've got a negative IX and a positive IX. Okay, so far so good. I've got a positive I and a negative I. And it works. All the imaginaries canceled out. So now I just have to combine some like terms. I only have one squared term, so there it goes. I have a negative x and another negative x, which makes negative 2x. And then I have a positive 1 and a positive 1, which makes positive 2. Okay, so when I multiply those last two factors, I get x squared minus 2x plus 2. So this line right here, well, the first line would be that complete linear factorization. So I'm kind of going backwards. That's what I was trying to get to yesterday. This is where I had to start today. So when I get to this line, when I multiply all those conjugates, this would be that factored over the set of integers form. And then finally, we're going to do standard form. So to do standard form, we take this binomial and distribute it through the trinomial. And when we do, we get x cubed minus 2x squared plus 2x. Now we distribute the 4 plus 4x squared minus 8x plus 8. And our final step would be to just combine any like terms we might have. So it's x cubed. We have a negative 2x squared and a positive 4x squared, which makes a positive 2x squared. Then we have a positive 2 and a negative 8x, which makes a negative 6x. And then finally, we just have the 8. And that is standard form.
This isn't that bad.
I would agree. It's not bad, but it is tedious. Yeah.
Time consuming.
Okay. So we're going to look at number 18 and do it together. That's the hardest one on the page. All right. So we have 1, 2, 3, 4 factors listed. Excuse me, roots listed. But there is a fifth one. You're right. Because if 1 plus root 2i is a factor, then 1 minus root 2i is also a factor. So this is going to end up being a fixed degree polynomial. Now, right here I wrote 0 and 0. I could have said there is a double at 0. I could have said it like that. So, we don't have a choice this time. Because we have a double root at 0, we can't just do x. We have to do x squared. Guys, that's called rain.
And I have to drive home today.
Oh, in the golf cart?
No, car, but
I have a golf cart.
Oh, okay.
And I have to walk so much.
It's okay. Maybe it'll settle before. Yeah,
If it
sometimes
gets
we get
harder-
those quick downpours.
If it
and
gets
then-
harder, I'm staying in.
That's smart. All right. So, let's take a look at the next root, 4. That would become x minus 4. That's right.
And then it will be x plus or minus, wait, no, plus 1 plus or minus 2.
Okay, so we have to subtract all of this, so it becomes a minus 1 and a minus root 2ix. And then over here, when we subtract it, it becomes a minus 1, but then this minus changes to a plus, yeah.
So you could
That's
say
where
x
the plus and minus kind of go. They go in here with that imaginary part.
Okay.
No, we're going to pick all. Except 2. 2 of them I'm doing for you. You're welcome.
So we only have to do 8 o'clock, which is 3 more.
And you have the rest of class after I finish this.
Cool, let's go.
Okay, so where will we start?
The imaginary.
You'll start with the imaginaries and knock those out. Now, let's take a look at 17. If I is a root, then negative I is also a root. So I didn't list it, but it's got to be 1. And then if 6I is a root, then what also is a root? Negative 6I. All right, so we got lots of imaginaries here. So what you would do on this one is these two get your answer. Then those two get your answer.
Wait, where are you 6
Well, if 6I is
Oh,
a
we're at
root,
17.
yeah, I'm just going back to that one for a second.
Okay.
So I was just talking about how you would start that one.
Okay.
You do these conjugates, do those conjugates, and then multiply those answers. That's the easiest way, because that's the way that eliminates I the quickest. Yes, ma'am.
Why do you have both as x minus 16?
Because I got distracted by my talking. Alright, so let's take a look at this one now. We got that one started. Let's go tackle the one we had begun. Okay, so we're going to distribute the x all the way through again. We're going to get x squared minus x plus root 2ix. Now the negative 1 is just going to change some signs for me. So it makes a negative x, a positive 1, and a negative root 2I. And then finally, probably the most difficult one to distribute is this one, negative root 2I. So that makes a negative root 2ix. It makes a positive root 2I. And then be careful here.
It makes a negative 4.
Okay, negative root 4, which is actually just minus 2. Square root of 2 times square root of 2 is 2. So it makes 2I squared, which makes that a plus 2. Actually, I don't like to mix those colors, so let's switch to white. There we go. Oh, that's so much prettier. Black and green is just not like together.
Is that a team or something?
The whole.
We might play them on Thursday.
Alright,
No, we won't.
so now we're going to do our canceling. A positive root 2ix and a negative root 2ix. A negative root 2I and a positive root 2I. That's it. And all the imaginaries canceled. Worked. Alright, so x squared, negative x, negative 2x. Alright, I know we got a negative 2 as our b on the last one. That is not always the coefficient of the linear term. We're just picking small numbers here to keep y'all from going nuts. And sometimes you get the same thing when we pick small numbers. Alright, and then we get a positive 1 and a positive 2 is a positive 3. So it's not exactly what we had a second ago. Now we have a choice here, guys. You could go ahead and distribute that x squared, or you can wait till the end to distribute the x squared. It doesn't matter. I'm doing it now. You can do it now or later.
Now.
And now we distribute again. So the x cubed needs to go through the trinomial, and it makes x to the 5th minus 2x to the 4th plus 3x cubed. And then we do the negative 4 through, and we get negative 4x to the 4th plus 8x cubed minus 12x squared. So our polynomial in standard form, x to the 5th, we got a negative 2 and a negative 4, which makes a negative 6x to the 4th got a positive 3 and a positive 8. That's right, it's positive 11x cubed minus 12x squared.
That's it?
And that's it.
I'm
Done,
liking
done,
this.
done. Okay, so you have the rest of class to work on the rest of this. Now, we only did 5 at the front. If you want more practice on the front, you've got 3 more you could work on. If you finish quickly, because I know some of you didn't pay any attention to me while I'm teaching and you're already done. And so, if you want to check your work as you go, there's not one of those great check steps like yesterday. Because we got that 0 every time that says, woo, you're doing good. It's like a high five. Good job. There's no good jobs on here. So, to check your work, you can check and see if yours matches your partner's. You can check my answer key, which is right here. Just ask questions if you got them.
Could you plug these numbers in
This?
I have no idea what you just asked. But let me come up.
plug the zeros in the standard form and see if it says zero?
Yes, you could.